So during the break, together with Dragon, we investigated what was going on, and the conclusion is that I'm a bad programmer. So there were two things. One, this was 01. I think we finished the last session with that. And the other one is right here, where we do the pre-processing. We had this instead of that. And this means that every time we have a position, say at 400, we just create a new table. But if we already had a thread at something 400, then that one is lost, whereas we would like to reuse it. Right, so that's why sometimes there were a few missing. Now we can get rid of all of this logging. But before we do that, it is interesting to keep these logs around. So let's add some logic to this function so that we can do that. So local debug is false, or in our case right now is true. And we're going to say, well, if we are debugging, then we would like to know what thread we found. Right, that would be interesting. So allocate pre-process all thread to find, to create lookup, to populate lookup tables for entire lands. Inform us about what we found. Print out all the air threads found, and similar, print out all the land threads found. Then we have, this one is fine. We can, so at this point, we know that we can remove all of this logic here, right? Because if we just have this check right here, twink, 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 and we have no wrapper anymore anywhere. Yep. Now we can see that they all match, right? So the thread that we would manually find afterwards matches with the thread that we actually have already during the pre-processing. So that's good. That means that we can now effectively remove this. We can effectively remove this, this, and this. And one could even argue that this is a bit silly that we have right here, right? If it's more than 0, then we add it in. So we could just write it like, whoops, like that. Because even if we would have 0 units, then that would still be valuable information to have. So populate the director. All right, that already simplifies some of the code. Now we still have this Fire-based logic that is going on here. And there's a couple of things that we could do with that. But given the fact that we are a bit on a time constraint, I'm going to leave this as an exercise for a lantern. No, I'm just joking. I'm going to do this next time and look into what's going on here and see if we can improve that. I think this is something like K clustering, maybe? I'm not entirely sure. But we'll look into that next time. We could also remove these two here. But considering that this is a chunk of code that we still need to investigate, there's no need to introduce any potential issues. All right, so about debugging. There's a couple of things that are really, really important when you are working with code that you're not going to touch for a while. In particular, if you are, for example, looping over this table that we have right here, it is very friendly to your future self to print out what this thread value actually, this table actually contains, right? So that if at any point in the future where your future self is going to look back onto this code, it's going to be wondering, well, what's actually in here again, or is it called position like that, or like, you know, with a capital P or a lowercase p, etc., etc., then you know now that it looks like this, right? And you could do the same thing there, but you gotta have it somewhere, and we decided to put it here. That's one part. Another part is that it may be interesting for ourselves to keep track of where these thread locations are on the map. So let's do that. Let's keep track of that. So we have local thread locations is some sort of table. So debug thread locations, and if debug, then no, that's not going to work. Debugging tools, local function, visualize thread locations thread, nice, is some function, and then we can say if we're debugging, then fork thread this little fella, and we're going to do a bit more. Debug threads is so that we can now say table.insert debug threads are thread. Local function debug cleanup. So what is the idea here is that we've got these thread locations that we want to work with. Debug cleanup fork thread, poof. Local debug tick is get game tick. In here, so every time we reload the file, this is going to get rerun, and we kind of want to clean up we kind of want to make sure that we clean up the previous threads during a reload, so that we don't have old debug information cluttering our screen. So let's do a wait seconds 10 in here, and then we do a get game tick. Let's look at what we're doing here. So if we wait 30 seconds, how often does this run? Right. Debug cleanup, debug threads. while true do and coroutine wait seconds 0.1. So we want to check if this file is still alive. Alright, what we can do is we get our reference to ourself is import /lu. Okay, this is gonna be beautiful. Let's go to here, and then we've got our function. This fella. Yeah, so we have this. We don't need this one. So we import ourself here. This is a reference to ourself. And here, other, we do this again. If self does not equal other, then reload it. Reload detected. We are no longer ourself. Spew or just log. Removing old debug functions. Fork thread.
I'm gonna make you explain that one to yourself in about 2 years.
Oh no. This is good.
Oh yes.
I can.
You're so pleased with yourself.
Yes, I'm very happy about myself right now. But this one, this is gonna be good. Fork comma thread in debug threads do kill thread. All right. Keep reference to ourself. All right, keep reference to ourself. Find reference to ourself. References do not match. Reload detected. We are no longer ourselves. This is very nice. And then in here we can do the coroutine. So coroutine.yelp2. And in there too. And what we want to do here is if we find this thread location, then we want to go over those. Fork v thread location debug thread locations do, and for each of these locations we want to draw a circle. Local position is these thread locations were two-dimensional, right? That's what we saw here. So what we have here is probably going to be two-dimensional too. So we're gonna fix that first. Log 1, 0, log 3, and then we can say position 2 is get surface height. Log 1, log 3. So we want to draw a circle at position with scale 10, and we're gonna make it red. No, I'm gonna go for white. So then we're drawing our circle. Now we want to populate this. We can do that right here. If debug, then populate thread locations. We could actually use the brain color. Can you access the color of the brain of the army? Do you know that, Sparto? Do you know how you can access the color of the army, of the brain?
Oh God. Like I would use that every day.
Right, let's not do that then. But that will be a nice quality improvement right here. But for now,
Yeah, I do something similar, but I use the color of the threat. I match a color to each threat type. The circle has whatever circle you're drawing represents the type of threat that you're dealing with.
oh yeah. That's that's what we do with the map utility thing in here too. And then we want to do the other way around, so we want to populate it again. Threat dot position. There we go. All right. So now if we start the game, we should be able to see where the AI is checking for threat values. And if we restart, then it should kill itself, right? It should remove the old debug functions. That is the that's the idea anyway.
Colors in the army table.
All right. It finds a few, but I can't see them. Get surface height. Attempt to use number and nil value. Right, that's... Attempt to use number as a nil value. Right. Removing all debug. There we go. So these were the locations that we checked. But by all means, we're only seeing them of one of the brains right now, because one overrides the other at the moment. So I think we are seeing it from Blue's perspective right now, but these are the threat locations that we are aware of. And that seems to make sense, right? So these are the iGrid. It has a clear vision of the base. It knows there's an army right there. It knows there's half a base here. It knows there's mass extractors here. I think this one's a bit off, but the idea here is that in practice, you want to be able to work with your data. In order to work with your data, you need to be able to visualize it. But let's make this slightly more robust, because right now it doesn't work for each brain yet. So let's do that. Let's make sure it works for each brain. So if debugging is turned on, then for k, brain in army brains do brain.debug threat locations is whoop. Right, so we no longer need this one here, and this one works with a brain instead. And here we do brain dot, and then instead of, we add in the brain argument. This is always a bit of an issue because this is part of an iterator, so I think we need to capture that, but let's see how it goes. And now we can get the color too, which is part of army tables. According to Sprouto. I don't know what army tables is, so let's look at that. Get army table. What is the sproto right here?
Yeah, here, hold on a second while I look it up.
Right, where the self is the brain in this case. So now we see both of them. Now we just need to color them.
Yeah, there's a function called getArmiesTable that will return a table of the armies in the game to you.
Get armies table. Get armies table. Okay.
And there's an entry for each army in the game, and a color is one of the elements in each entries.
And then there's an actual dot armies table.
Yeah.
Okay, and then here we have color is food brain get army index dot color with a small lowercase.
Yeah, lowercase.
Perfect.
And it is returned to you in the RGB format. ARGB, sorry.
Why is this not correct? It's being a bit angry right now. Let's restart. No, not scenario. Am I still recording? Yes, I am. Oh, 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 oh. It crashes. Show me why. 72. Right. Let's try that again. Access to the non-existent global variable get armies table. Did I mistype that?
I don't know.
Oh well, doesn't matter. We can just put it in there. So we're not seeing them yet. We would have expected to see them by now. Log color. There is more errors. 69. Get armies table. Why is it crashing on that one?
No idea.
Did I mistype it?
GetArmiesTable? Let's find out.
Oh, but it's a user function. What's the sim function of it?
I think it's already in memory.
List armies.
List armies.
Of course. Invalid color must be a string. Show me those. Invalid color must be string. What is enlist armies? No, that's not what we're looking for. Huh? This information is available on the sim site.
Yes. Using it.
Yeah, so where is it then?
What are you seeing from the army? What are you seeing from list armies?
Just literally a list of armies, the army names.
Oh, perhaps the data is not being inserted. Maybe we're inserting color after the fact in loud.
You cheaters. All right,
Anyway,
let's.
if you want to see an example of if you look at the stream that I've put up, you
Yeah.
can see how loud does a very similar thing. We're showing the IMAP blocks. The color tells you the type of threat, the magnitude of the radius, the circles around the.
Yeah, that seems fair. That's kind of what I wanted to go with too.
Yeah. The only difference here is that in loud we localize the threat within the IMAP block. That's why those circles will be off center in the block
Yeah,
rather than just applying it to the block.
but you don't use the army color for that, or?
No, we have a color table for each type of threat.
Yeah, exactly. All right. But we should be able to get the generate army start. I know this got to be somewhere. Damage ring. Create slider. This is the best part of the session of today.
There it is.
Army civilian. Add build restriction. That is odd. I recall this being possible. V in brain do. Two string K. Two string V. $71. Right, so we're gonna add the concatenation. Oh, share screen. Wrong one. I want to stop watching Smarto stream. Ah. Okie dokie. Is there something called a color in here? Name? Nickname?
It should be stamped on the brain.
Yeah.
It's not.
No, it's not. That's odd. I really thought that that function existed somewhere.
Yeah, you would think so. Doesn't look like it's in the sim by default. Obviously they use it for chat and all that stuff, so it's in the UI.
Oh well, that's something for next time then. But the idea here primarily was that we could make it easier to see the data that we're working with in this case. And
talking about RNG's Intel data.
say again, Sparto?
Sorry, this is RNG that you're working with today?
Yeah. Yeah, so what we did, there was a function called tactical threat analysis, and he told me that it was not very efficient. And I told him, no. And I told him that I'd look at another function, but I decided to look at this one because this one's easier to test. And we removed some small gotchas, some big gotchas. So that's
Yes. I think this was originally constructed off of Saurian's threat analysis code.
that could very well be the case.
Yeah, I think it was the case. The threat locations, and I think there was another section for fire bases and such.
Yeah, right here.
Yeah, those are hallmarks of that code.
Yeah, that's something we didn't look at, or we're not going to look at tonight. I'm still recording.
Yeah, no, it's not relevant.
Because that's, well, it is relevant, but it's just that it's a huge chunk of logic that we just didn't have the time to do. But that is it for now. So there's a small summary that I'd like to give. Cache your categories, please. And if you, for example, in this case, with the shields, right, we only scan once per field instead of for each unit. That's going to be quite a bit of difference. And we can now safely conclude, right, if we would remove all of these log statements, and we would remove, set this to false, so there's no debugging of this either. Let's just look at how long this function really takes to complete. And 0, 0, but right now there's not much going on, right? So that's fair. Still 0. Oh, we're still drawing circles. Let's get these out, help us debug. Time analysis is still 0, so and we do have threat blocks, right? Let's just make sure. Yeah, we do have threat blocks. It's just that the analysis is so small that it's barely noticeable, so that's good. So with that, I think we can conclude that this function is now fine. There's no wait statements anymore in it. There's still a couple of things that we can do, however, to improve it further, besides tackling this Firebase logic. So as an example of one of the things that we can do is we create these lookup tables, but we could easily reuse these, right? So we could put the lookup tables here, and then first remove all the previous entries, or set those to 0, and then populate it again, like we do here, right? So we remove all the previous entries and then we populate it again. we could do the same thing right here, where this is the populating part, and then we would need something to clean up all the entries that are currently in there. That would definitely be good, because these tables, they can have up to 50 values or something like that we saw last game, right? Where these get half. That's something else. They can have...
Sampling all of IMAP, you can easily have 50.
Yeah, you can easily have that, yeah. There's more that we can do. For example, this one's a bit more tricky, but this is totally possible. We create a new table for every unit that we find inside those IMAP cells. But instead of creating a new table, we could reuse existing tables and just remove the ones that we no longer need. So in this example here, we start with an empty table, but we could just not reset everything, right? We could just not do this, and instead of using RNG insert, we keep our own separate counter, and then keep overriding the existing table until we are satisfied, and then we remove all the other entries that we no longer need. That would definitely be still another big improvement for your memory, the memory side of the question, right? Because these tables are not small; they're pretty decently sized, and that would still be a nice improvement. And I had something else in mind, but I think we already did that. Yeah, so this would be a very small change, but if you look at here, we create an empty table just to reallocate that into another table that's potentially empty. So either we, instead of populating this local table, we populate this table here directly, or we just don't define half of these values. Note that combat is, for example, is not even used. Neither is mass, but maybe those are part of other functions. That's not in this threat analysis here. Either way, Relenter, if you're watching this, if you're still here, I hope this gives you a few pointers as to how you can look at the code and how you can make it more performant. There's something else that I wanted to tell you real quickly too, so I'm gonna just do that. And that has to do with your platoon and then your true platoon RNG. One thing that's particularly important with this function is that all of these local function definitions, they are recreated every time this platoon function runs. So every time you create a platoon, they'll have their own little version of get weighted health ratio with its own closure that will reside somewhere in memory, which is a bit of a waste, right? Because I understand that these are local because they're only used in this function, but because they're local, it means that they're recreated each time. So what I would advise to do at the very least with this function is the same thing what we did here, right? We create a new file for specifically testing that one function, right? So the technical threat analysis, RNG in this case. And then these local definitions here would just become an up value outside of the function, which would be already, in terms of this function, a nice improvement, because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21 closures that are being created, and these are the ones that are not part of another closure inside, right? So we have, for example, this one. Every time you call variable kite, it will create a new closure. Three new closures actually, which is painful. That makes the function a lot more expensive, even though these functions do not rely on any of the outside data, right? It's completely pure in terms of their arguments. So I would definitely do that. In general, having a separate file like this can help you with a lot of things. One is debugging specifically for that function, like we're doing here, right? And easy way to clean up the debug functions. Another is that you can easily cache these categories. You should definitely always do this. This is gains, easy gains right there. If you, for example, look at your function here, there's a couple of category computations here too. These are arithmetics. Those are recomputed every time your code passes this line. That is the definition of a waste. It is a one-time use. And the same applies to these longer ones right here, or these type of tables that you have right here. If you can cache those, cache them. It is worth it. Yeah, so I think this sums it up. I'll make sure that this ends up somewhere on your GitHub Relenter. Not sure how yet. And I hope that this helps you with, for example, a different approach to debugging functions, to making iterations on a function, right? Because we were making live iterations while we were changing the function. And give you an idea of how to write better performing code. That's it for me.